Hello, John Zimmerman with Tablet Class Math, and in this video, this is just kind of a what's the word here? Not really going to be a math lesson. It's more of a little conversation on celestial navigation and my appreciation for math and what it's able to do. So, if you're interested, hopefully you'll stick with me for a few minutes and learn something about navigation. And specifically, celestial navigation is navigating or finding our position on Earth by using primarily the stars, but you can use the sun and the moon. So it's actually a pretty involved skill to be able to do that, but and it involves a pretty good amount of math, trigonometry specifically. But anyways, what I want to do here is hopefully I'm going to do a good job at it. Is give you a basic idea of celestial navigation and how navigators are able to find themselves on Earth. So it can be, hopefully I'm not going to mess this up. Hopefully it's not going to be too confusing. And so here we go. All right. So it's very interesting though if I do this correct. All right. So let's say here we are here. Let's imagine this is the open ocean. Actually, this is Florida. This is near where I live. I love Florida. So we can see the land, but let's just suppose we didn't see the land and we're out in the middle of the ocean and we need to find our position at sea. Okay. So how are we going to do that? Now, let's say there's no cell phones. You have no electronics on board. You have no GPS and you really have no idea. Well, what you can do is use celestial navigation to help you out. So here's the basics of how it works. All right, so let's say I'm out there and let's see, I see a star here, okay, and I recognize that star. I just know that particular star in the sky is star A. I'm just going to give it a name, star A. Okay, and let's also suppose that right now the time is 6 p.m. Okay, now if somebody out there is watching this video and actually knows how to celestial navigate, clearly I'm going to be oversimplifying, but I think for most everybody you'll get the basics of what I'm talking about, and that's the whole purpose of the video. All right, so here I am. I'm out in the middle of the ocean. I see star A. Okay, I know it's star A, and it's 6 p.m. Now, from my location, okay, I see star A, let's say, at 50 degrees above the horizon. Now, how would I get that measurement? Okay, so the way I would get that measurement is using a nautical instrument. You've probably seen it. I'm going to try to sketch it real quick. It's called a sextant. Okay, it looks like this. You've probably seen mariners using it. And what they do, they pick this thing up, they look through it, and then they kind of swing something back and forth, and it's able to tell them the angle of an object above the horizon. And really do have to be very specific with these measurements. Okay, so anyways, I take my sextant out. I know it's 6 p.m. and I look at star A and I'm seeing it 50 degrees above the horizon at 6 p.m. on this particular day. All right. So what does this mean? Okay, if I have those two pieces of information, I'm on my way to finding my position at sea. Well, there is a book that navigators use. Okay, and oh boy, if I'm not mistaken, I think the book is called like HO 229. It's kind of a weird name for a book. It's been a long time, but anyways, it's essentially a reference of all these stars that we look at, these primary stars that we use for navigation. And I go to this book and I'm saying, okay, it's 6 p.m. and I'm looking at star A, and the book will tell me, well, star A should be located at this position, okay, at 6 p.m. Okay, at 6 p.m. you should be seeing star A directly over your head, 90 degrees, right? So if I'm standing out here in the middle of the ocean at this position, okay, not where I'm at, okay, at this particular position, I would see star A directly above my head at 90 degrees. Okay, so if let's suppose if star A just fell straight down onto the Earth, it would be at this position at 6 p.m. Okay, so hopefully that makes sense to you, right? So if I'm right here and I'm looking at star A, I would be looking straight up, right above my head, up in the sky. But obviously, at 6 p.m., I'm looking at star A and I see it at 50 degrees in the sky, not 90 degrees, not above my head. So with those two pieces of information, okay, I can use some trigonometry. Okay, this is going to be a right angle. I have a degree here. I have a location here, and I'm not going to get into the math because that's not the purpose of this video. But essentially, what you're able to do, what the book is able to do, is to say, listen, if you're seeing star A at 50 degrees, okay, and not at 90 degrees, well, the only way you can do that is that you have to be a certain distance away from its location at 6 p.m. Okay, and it's basically going to build us a little circle here. So let's just make a number up. Let's say in order to see star A at 50 degrees, okay, at 6 p.m. at night, you have to be 900 miles away to be able to see that observation. Okay, well, I could be 900 miles here, or I could be 900 miles anywhere along a big circle, right? I could see that same observation over here. Okay, I could be over here at 6 p.m. and still see that at 50 degrees. So that's not really helping me either, because I could be here, I could be here, I could be here, I could be here. All these positions are 900 miles away from star A's location. And I can see the star at 50 degrees at all these various positions. So how could I help myself out here? I mean, it's better than nothing. I mean, at least I know generally that I'm along this circle, if you will, at 6 p.m. And by the way, the technical word for this is what they call an LOP, line of position. So, well, you're looking at it as a circle, but technically we call it LOP, a line of position. So I'm along this, somewhere along this circle. Okay, and of course the circle just continues out. So it's a start. So how can I help, really get an accurate idea of where I'm at? Well, I look in the sky and I look for something else. Okay, I come over here and I see, lo and behold, I see star B twinkling over here. And I'm like, oh, star B. Let me go ahead and take a look at you at the same time. Well, actually, let's say it's 6:01 or 6:02 p.m. And I do the same thing with star B. And I go through the whole rigmarole, just as I did here. I measure its angle, I look in the book and everything else, and the book tells me, hey, the only way you could be seeing star B at this particular angle is you would have to be along, let's say, this line, okay, this line of position. So now I have two lines of position, all right? I can be seeing star B, say, somewhere along this circle at 6:02. So you can see where the two lines or the two circles are crossing seems to be the obvious place where I'm going to be at, right? And that is called a fix in navigation terms, F-I-X, a fix. And that's your position based upon your navigation efforts. So that's the basics of celestial navigation. And let me just actually throw something else in. If I wanted to make my fixed location more accurate, what could I do? Well, if here I use two stars, maybe I want to look at another star, star C. And I would continue to get more and more lines of position, more circles. So you could see it gets pretty involved. And actually, when I was in the Navy, and I don't know if you know this or not, but in a former life, I was a U.S. Navy officer. I was a surface warfare officer, and on one of my tours, I used to navigate a billion-dollar warship. That was my responsibility. So I had a bunch of people, a bunch of equipment, and I took this stuff very seriously because I had to. But I would say for our team, probably take us anywhere from say 15 to 30 minutes of observations with our sextants and doing some pretty good level of mathematics to work out and get these positions. So if it looks involved, that's because it is involved. But the thing about it, the beauty about it, is without any electronics at all, simply armed with a sextant, a book, and some math, okay, and obviously some training, you can locate your position anywhere on Earth. And I think that's really cool. Using the stars, I mean, that's amazing. And then the other thing too is you should really get appreciation of how ancient mariners, how they established trade throughout the world, and of course all you history buffs can kind of really get into the value of navigation, how it plays its role in history. It's really amazing. Anyways, hope you enjoyed the video. Hope you learned a little bit, at least, about celestial navigation and math. And If you enjoyed this video, please follow me on YouTube, or rather come on over to tabletclass.com. Maybe you want to take a free trial. But anyways, thanks for spending a little time with me, and have a great day.